Hello, this is Ryan, and this is lecture for math reasoning for March 31st. What I wanted to start with today is really a motivation of how much properties about numbers we take for granted. We could really talk about any piece of mathematics here, but let's talk about the quadratic formula. Okay. So this problem was the first known entity that really studied this quadratic formula is by Babylonians. How they phrased it is a little bit different from how we usually phrase our quadratic formula problem. So let's go through that. For them, it was more of a geometric problem. So let's say that we have a rectangular field and we're given two pieces of information, the parameter, let's say this is length and width. The parameter is 2L plus 2W. And then the area is given by length times W. Okay. Notice that the parameter is 2 times length plus width, right? So if I give you parameter, that's really the same as knowing what the sum of L plus W, what that is equal to. So let's say we're given the sum of two numbers, L and W, or X and Y, X plus Y is equal to sum S, and X times Y is P for product, S for sum. And we want to know what kind of rectangular field gives these two statistics, right? The sum of the length and width and the area. Okay, so what we could do is we could take the first equation 1 and solve for y. So you could just say y is equal to s minus x. And we can plug it into the second equation, right? So if I substitute y in the second equation, we'll get this equation, x times s minus x is equal to p. Okay. If we distribute the x here and bring it all over to the right-hand side of the equation, we could rewrite the equation as x squared minus sx plus p equals to 0. This really is, so being able to solve this equation is really equivalent to solving for x in the general quadratic equation ax squared plus bx plus c equals to 0. Really, the only difference is that if you have, as long as a is non-zero, you could substitute b for negative as and c for a times p. Then the equation becomes equivalent to the equation over here. You just have to divide both sides of the equation by a. So being able to solve this geometry rectangular field problem is really the same as being able to solve quadratic equation in general. Okay, so let's solve it. So what we could do is from this equation, we could factor out a from the first two terms. So we have a times x squared plus b over a times x. And inside the parentheses, what we could do is what's called the completing the square, right? So we add and subtract b squared over 4a squared. This is chosen so that if the first three terms, these three terms, turns into a perfect square. Perfect square is going to be the x plus b over 2a. You just take this middle term and divide by 2, and that becomes the term you add inside of the square. So x squared is equal to x squared. The cross terms x times b over 2a. There's two of the cross terms, so if you add it together, you get the middle term. And b over 2a squared is the b squared over 4a squared. It was chosen precisely so that that works out. Okay, but adding the extra term requires us to subtract the equivalent term. So that's what we have left over here. And we can multiply back in the a that was sitting in the outside. And here's what we get after that. Okay. We're almost there. So if we bring the non-square term over on the other side, this is the equation we get. What we could do is we could get a common denominator with c and the first term here, and divide both sides by a to get the next line. To get rid of the square, we could square root both sides, remembering to take plus and minus the value there. And then all we have to do to get x by itself is subtract b over 2a from both sides of the equation. And here's what we get. This is the quadratic formula as we know today. All right, so a few things to watch out for. If b squared minus 4ac is a positive number, this will give two different solutions, right? Because of the plus or minus there. If b squared minus 4ac is exactly equal to 0, I'm adding or subtracting 0. So you really only get one value for this equation. And if b squared minus 4ac is less than 0, then there are no solutions, at least no real solutions. Okay. All right. If we substitute in terms of the original problem as Babylonians phrased it, the quadratic formula becomes this guy right here. Okay. And it could be solved as long as inside of the square root is non-negative. Okay. All right. So at this point, I kind of want you to pause this video and check that this really does solve the original problem. So we get two solutions, right? Plus or minus this expression. So let's call the x is the s plus the rest, and y is the minus version of the same equation. And I want you to check that when you add those two things together, you get s as we wanted. And when you multiply it together, you get p. So try that out. Okay. All right. So what I want you to now kind of focus on is how much things we really have to assume to work out that mathematics. We really added things in any order we chose, right? In fact, we shifted the terms around from left-hand side of the equation to the right-hand side of the equation without any thought. We added and subtracted things in the middle and kind of to create like a perfect square. And multiplication too, we kind of did that in any order we chose. We used distributive law, right? We factored things out, multiplied things back in. That's a rule that we kind of take for granted, but that's we assume that that's correct. We subtracted things. I mean, that seems like a really basic thing, but really, um, assuming that there's some additive inverse to a number is an assumption that we're making. Not everything we could do is invertible. And same with division here. Division is kind of like the inverse of multiplication, right? Um, we also looked at some properties of inequalities. We use those properties for granted. We assumed that the square roots exist. There's a number such that when you multiply by itself, you get the thing that you are expecting to get, and those things exist when the inside of the square root is non-negative. Okay. Um, we I mean, this is kind of like subtraction, but we kind of assume that negative numbers are numbers. Um, this wasn't even a thing for Babylonians. So there's a thing that's assumed there that negative numbers actually make sense. Okay, so these are very intuitive things that we took for granted up until now. And you might seem like, well, yeah, those are what numbers do. But we need to give those things names, and we need to see how. So things like quadratic formula. If you want to believe that quadratic formula really does solve quadratic equations like we expect, those things really rely on all of the assumptions that we made to make this calculation. So that's what's going to be our starting point for this class. So we're going to give these assumptions that we kind of intuitively have about numbers. We'll give each of those facts names. Um, and those will be our starting truth for our class. What I mean by starting truth is that everything else we'll do in this class will build from that. We'll use those as facts and prove theorems about numbers. So that's what we'll do. This will come at the end of the chapter, so we'll actually won't get there until next week. I think we'll get there Tuesday next week. But this is our motivation for trying to nail down the basic facts about numbers that we're going to be using.